Hi, hello friends, welcome to our channel Study of Mathematics. Next, we go to ninth property. In the properties of a determinant, the ninth property is that the sum of the products of the elements of a row or column with the cofactors of the corresponding elements of another row or column of a square matrix is 0. This is the ninth property. The ninth property is that the sum of the products of the elements of a row. If we take a matrix A, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. This is a matrix of square matrix. If the sum of the products of the elements of a row with the cofactors of the corresponding elements of another row of a square matrix is 0. That means we can select any one of the row products of the elements of a row with the cofactors of the corresponding elements of another row. If we take this is R1, R2, R3, we can use R1 and R3 rows in this. For explaining this property, we can use R1 and R2 rows. Take the elements of any one row. We can take R1 row. R1 row elements are A1, B1, C1. Sum of the products with the cofactors of the corresponding elements of another row. ఈ ఎలిమెంట్స్ని అనదర్ రో యొక్క కరస్పాండింగ్ రో అంటే A1కి A2 కరస్పాండింగ్, B1కి B2 కరస్పాండింగ్, C1కి C2 కరస్పాండింగ్ అవుతుంది. కాబట్టి వీటి యొక్క వాటి కరస్పాండింగ్ రో యొక్క కోఫాక్టర్స్తో మల్టిప్లై చేసి వాటిని సమ్ చేస్తే వచ్చే వాల్యూ 0 అవుతుంది. A2 యొక్క కోఫాక్టర్ హియర్ టేక్ A2 యొక్క కోఫాక్టర్ మ్యాట్రిక్స్ ఏమవుతుంది? హియర్ సమ్ ఆఫ్ ద ప్రోడక్ట్స్ ఆఫ్ ద ఫస్ట్ రో, sum of the products of the elements of a row. Here take first row with the cofactors of the corresponding elements of another row. That means with the cofactors of the corresponding elements of the second row యొక్క cofactors యొక్క ని ఈ ఎలిమెంట్స్ ని మల్టిప్లై చేస్తే కోఫాక్టర్స్ ఏమొస్తుంది? క్యాపిటల్ A2, క్యాపిటల్ B2, క్యాపిటల్ C2. Then this addition value is equal to 0. This addition value is equal to 0. This is the property definition. That means this is nothing but the sum of the products. వీటిలో ఏదో ఒక రో యొక్క ఎలిమెంట్స్ని దాని కరస్పాండింగ్ రోలోని ఎలిమెంట్స్ యొక్క కోఫాక్టర్స్తో మల్టిప్లై చేసి వచ్చిన 3 వాల్యూస్ని అడిషన్ చేస్తే వచ్చే వాల్యూ 0 అవుతుంది. దిస్ ఇస్ ద ninth property. Next, 10th property is that if the elements of a square matrix are polynomial in X and its determinant is 0 when X equal to A, then X minus A is a factor of the determinant of the matrix. In below all properties, we can use matrix as a elements or matrix elements, but in this property if that in matrix we have that elements are in polynomial form. That means if capital A of X or in polynomial matrix is also in polynomial form, capital A of X, this is F1 of X, F2 of X, F3 of X. Next, Z1 of X, Z2 of X, Z3 of X. Next, H1 of X, H2 of X, H3 of X. This is the polynomial square matrix in X. This determinant is 0 if mod AX1 is equal to a of x is equal to 0 when here x equal to a. When x equal to a. Already we know in polynomial in previous classes, if any polynomial f of x is equal to 0 when x equal to f of x equal to 0 when x equal to a, then x minus a is a factor of the function f of x equal to 0. Then by using that property in this matrices, mod determinant of a of x equal to 0 when x equal to a, then x minus a is a factor of the determinant of the matrix a of x. In polynomial, f of x equal to 0 when x equal to a, x minus a is a factor of the function f of x equal to 0. In matrices, the determinant of the matrix, polynomial matrix a of x equal to 0 when x equal to a, then x minus a is called the factor of the determinant of the matrix a of x equal a of x. This is the 10th property. Next we will go to 11th property in the same properties. Next 11th property. For any square matrix A, determinant A equal to A transpose. Already we know if A equal to matrix A1 B1 C1, A2 B2 C2, A3 B3 C3, this is a matrix A, then the transpose of that matrix A transpose equal to A1 B1 C1, A2 B2 C2, A3 B3 C3. Transpose means we turn rows into columns. Then in this property, if the determinant of A is equal to determinant of the transpose of a matrix, that means that A equal to that A transpose. If A is a square matrix, then the determinant of the matrix A is equal to the determinant of the transpose of a matrix. This is 9th property. Next, the 10th property is that determinant of AB equal to determinant of A into determinant of B. If we can find the two matrices product determinant value is equal to the individual matrices determinant product. That means if A of order 3 by 3 and B of order 3 by 3, then AB is possible. AB matrices determinant value is equal to the individual matrices determinant product. That means that AB equal to that AB. This is true for order 2. That means 2 by 2 matrices also prove this property, and 3 by 3 matrices are also prove. Similarly, by using the mathematical induction property, we can easily say that this property mod AB equal to mod A into mod B, or det AB equal to det A into det B value is true for all matrices of order n. 2 by 2 matrix అయినా కూడా det AB value det A into det B value కి equal అవుతుంది. If the matrices 2 matrices are square matrices of order 3, then also this property is true, that AB equal to det A into det B. Similarly, by using the mathematical induction property, by using that property, we can easily say that the determinant of the AB equal to determinant of A into determinant of B for all order n. This is the 12th property. Next, 13th property. Next, 13th property is for any positive integer n, determinant A power n equal to determinant A whole power n. In the 12th property, we know that determinant AB equal to determinant A into determinant B. If we take A, B in the place A, that is determinant A into A, that is equal to determinant A square. Determinant A square. Here, that is, here we put B equal to A, then determinant A into A, that is equal to determinant A into determinant A, then determinant A square equal to determinant A whole square by using the 12th property. In the same way, if we use in here two matrices, if n is any positive integer, a power n determinant value is equal to determinant of a whole power n, then a power n యొక్క determinant value ఆ determinant యొక్క whole power n కి ఈక్వల్ అవుతుంది. if for any matrix a cube తీసుకుందాం, a cube యొక్క determinant value determinant a whole cube కి ఈక్వల్ అవుతుంది for any integer n. Next, last property, 14th property is that if A is a triangular matrix, that is an upper triangular or lower triangular, then determinant of the A is the product of the diagonal elements. If A is a triangular matrix, then the determinant of a matrix A is the product of the diagonal elements. The 14th property is if A is a triangular matrix. In triangular matrix, we have two matrices that are upper triangular and lower triangular. First, we can take upper triangular. Upper triangular matrix A equal to, if a matrix is said to be a upper triangular matrix, then the A, B, C 0, D, E 0, 0, F. Then this is a diagonal or principal diagonal. The lower part of the principal diagonal elements are all unequal. Then that matrix is called upper triangular. If the above elements of a principal diagonal elements, then that matrix is called lower triangular. Then we can easily draw lower triangular. Lower triangular matrix A, B equal to A 0, 0, B, C 0, D, E, F. This is the diagonal elements. The above triangular part is 0, then that matrix is called lower triangular matrix. Then these two matrices cases, these two matrices determinant value is equal to product of the diagonal elements. Then in upper triangular matrix, the determinant value that A equal to A, D, F, product of the diagonal elements. Product means A into D into F. In lower triangular matrix B, the determinant value is also equal to the product of the diagonal elements, that is A, C, F. This is the property 14. If A is any upper triangular or lower triangular matrix, then that matrix determinant value is equal to the product of the diagonal elements. This is the 14th property. All these properties are most important for further problems or future exercises and example problems. After these properties, we solve or we explain most important problems for examination pattern. In after SOM, this we discuss the many important problems for examination pattern.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.